Alright, AP Calculus class, as you can see, I am not there. I will be back today afternoon. However, I will be missing your class, so therefore I went ahead and made a video so that you can follow along with me. Tomorrow you do have a quiz, and I do have a review for you so that you will be aware of what actually will be on this quiz. I should leave a hard copy for each one of you all to keep, but I will quickly just go through these questions, and these are basic questions. Well, actually, you know all of this information. You just probably haven't been exposed to the alternate ways of how each question will be asked. So let's just quickly go over number one. It says that you have f of x as x approaches c is equal to 6, and the limit of g of x as x approaches c is equal to negative 3. So we're going to use the property of limits. So for a, it says basically f of x minus g of x, the limit of that as x approaches c. That's very nice and simple because all you do is just basically, in a way, distribute that limit to each of those. So you really have 6 minus a negative 3. And that gives you 9, and of course the limit of a constant is a constant. So the answer to 1a would be 9. Let's look at the limit of 2g of x as x approaches c. The 2 is considered to be a scalar, so what can we do with that 2? We can always kick it out to the front. So we're left with 2 times the limit of g of x as x approaches c, or in reality 2 times a negative 3, which would give us negative 6. Here we basically do the exact same thing. We substitute whatever the limit of f of x as x approaches c is. In this case it's 6. Once we do that, we go ahead and square it, which will give us 36. Here for 1D, we will do the same thing. We will distribute the limit to each one of those functions. So it's as if saying the limit of f of x as x approaches c times the limit of g of x as x approaches c. So in other words, we have 6 times negative 3, which will give us negative 18. If we look at number 2, A, B, C, D, E, and F, those are very simple. I think almost all of y'all are very good at these. So let's take a look at the first one. It says the limit of f of x as x approaches 0. Remember, if I'm giving you a picture and I'm asking you for a specific limit, you have to approach both from the right and from the left before you can even answer the overall limit. So if we look at f of x as x approaches 0, here is x. If I approach from the right, that y value is 1. If I approach from the left, that y value is also 1. Therefore, my answer for this one will be 1, because both the right-hand limit and the left-hand limit are the same. If we look at f of x as x approaches 6, 4, 5, 6, here it is right here. If we create a wall through this vertical line, through this vertical value, if we approach from the right-hand side, that's this little piece right here, we hit that wall, that y value is 2. If we approach from the left-hand side, that's still this piece right here, we hit that wall, and that y value is still 2. Therefore, the overall limit of 2b would be 2 as well, because the right-hand limit and the left-hand limit are both equal. Let's look at f of x as x approaches 3. Here is 3 right here. You create your vertical line through this value here. If we approach from the right-hand side, that's this piece right here, we approach it from the right-hand side, that y value is 2. However, if we approach it from the left-hand side, that y value is 1. 1 does not equal 2, therefore the limit overall for c does not exist. Okay, let's look at negative 3. 2D, the limit of f of x as x approaches negative 3. As you can see, negative 3 is considered to be an asymptote. So we know that a function would not exist because it would never be touched. So that's a function, though. We're looking for the limit at the moment. So if we look at the limit, if we approach the asymptote from the right-hand side, that's going to go upwards to without bound. So it's increasing without bound. So basically, we represent that with a positive infinity. If we approach from the left-hand side, it's decreasing without bound, so we represent that with a negative infinity. So a negative infinity and a positive infinity are not equal, therefore the answer for D would be does not exist. Let's look at E, the limit of f of x as x approaches negative 5. So we have negative 5 right here. Create your wall, and let's approach both from the left and from the right. So if we approach from the left-hand side, that's this piece right here, we follow it until we hit our wall, and that y value is 0. If we approach from the right-hand side, we follow it until we hit that wall, and that y value is 0. Notice this time that the difference there was not a shaded circle in there, but that shouldn't even bother you at all, because you still would get the same answer. You would apply the same concept. So in this problem for E, it would be 0 for the limit. Let's look at f, the limit of f of x as x approaches 2. So if you notice here is 2, and we're probably going to have to estimate a little bit on this one. Let's see what we can do. The limit of f of x as x approaches 2. So here is 2 right here. If you create your wall, and we approach both from the right hand side and from the left hand side. So if we approach from the right hand side, that's going to give us a value a little bit underneath 1. So if you had to estimate, maybe about let's see, 1.7. I mean, less than 1, so it'll be a little bit about 0.7 if you had to guess, maybe 0.8. And then if we approach the limit of f of x as x approaches 2 from the left-hand side, so if we're approaching from the left-hand side, that's this piece right here, and it would still be about a 0.7 or a 0.8. So for f, we would say that they would exist at around 0.7, 0.8. This one you would probably have to most likely estimate, but you would have to estimate realistically. I don't want you to, for example, just say that it is 0.5, because I don't think that clearly it's not 0.5 on either of them, since 0.5 really is in between here and it's not in the middle. So use reasonable estimation for f. Okay, now let's go ahead and look at evaluating each of the following limits. For a, direct substitution works, so you have 8 minus a negative 1, which would give us a root 9, and the square root of that is 3 at this point. If we go ahead and approach the limit as x approaches to a sine of pi x over 3, direct substitute, so you get 2 pi over 3. And if you, I will give you a unit circle, so let's go ahead and look at that unit circle. In case you don't know, sine represents the y value. So we're going to look for 2 pi over 3 and look at the y value. So let's look at that. Here is 2 pi over 3 right here. That y value, because it's the sine, is radical 3 over 2. So we got this one, we got this one. Now let's go ahead and do this one. If we direct substitute, that lets us know that we can, because we don't get a 0 at the bottom. So we get 3 plus 3 at the bottom, which is 6. 3 minus 2 on the top, which is 1, so we get 1 over 6. D would still be direct substitution, so it would be negative 2 squared, which is 4 minus 3 times the negative 2, which would convert into a positive 6. So 4 plus 6, which would be 10. Here for 4a, we can definitely find this using our trig identity, that the limit of sine of x over x as x approaches 0 is equal to 0. So to 1. And so you basically would need to play around this and figure out what our answer will be. And again, I'll probably go over this one before we start the quiz on Tuesday. B, again, is a multiplying by the conjugate. I'm not going to go over this because you should probably already know how to do this. So A and B would be good ones for someone in the class to go over and figure it out. I will probably leave you the answer for both A and B on the board, but you figure out as to how to get to that answer. And finally, let's look at number 5, discuss the continuity at x equals 0 from the graph in number 2. Remember that in order for something to be continuous, the function has to exist, the limit has to exist, and both the function and the limit have to be equal to one another. So if we look at x equals 0, here's x equals 0 right here. Anywhere in there did I go through a shaded circle? So in other words, what is f of 0? I did not go through a shaded circle. So in other words, f of 0 doesn't exist, okay? So that's case 1, f of 0 doesn't exist. Now let's look at the limit of the function as x approaches 0, which we discussed in 2a here. But we'll go over it again. The limit as we approach from the right-hand side is 1. The limit as we approach from the left-hand side is 1. So we have case 1, the function, so f of 0 does not exist. Case 2, the limit of f of x as x approaches 0 is 1, and then we could say that case 3, f of 0 does not equal to the limit of f of x as x approaches 0, and therefore x equals 0 is not continuous. It is not continuous at x equals 0. The function is not continuous at x equals 0. You will have to do one of those on your quiz. So that's the basic idea of what your quiz will cover tomorrow. And hopefully it was pretty easy for you. Now I'm going to go ahead and explain to you what I want you to do for the rest of the class period. Now for the rest of the class period, you will be given, let's see, this right here should be familiar to you. It was a worksheet entitled A Beautiful Function, which we did in class last year. We did this in class last year. So let's take a look at it right here. Actually, you know what? We're going to go ahead and do actually this page, because we already did a beautiful function. So we're going to do this page right here. Let's see. I didn't realize I had it in here. I forgot it was 2 documents. So what I want you to do is this part right here. You're given a function right here, and it says to find f of a. Then we're going to find the left-hand limit, the right-hand limit, the limit overall, and then is it continuous? So that's what we're going to do. We're going to do for those. So if for the remaining of the class period, go ahead and fill out this table, and then from there we'll figure out, or from there I will ask tomorrow in class what you got for some of your answers. Okay, so just this part right here is what I want you to complete. Alright, so if you have any questions, remember I will be back today after school, and we will have a quiz on tomorrow, which we already discussed and reviewed over. Other than that, I hope that you have a great day, and I expect to see you tomorrow. Goodbye.